Obviously, lithium ion in the basic chemistry like LFP and NMC are the most mature in the segment. That's why you see almost all vehicles today running on these technologies. But eventually, different pockets will emerge and different technologies will win in individual pockets. That's it. Look at the entire spectrum of electric mobility, starting from your two-wheeler, three-wheeler kind of vehicles, and all the way up to buses and trucks, which go between cities for long distances. Different platforms have very different, so to say, requirements when it comes to the battery pack, like that the kind of power draw they want, the kind of life they want, the kind of so to say performance and range that is required. So if you look at the two-wheeler, three-wheeler segment, which is primarily the intra-city segment, and if you look at that segment, these vehicles hardly leave the city limits. So range is not that big of a concern in these vehicles. But what is a challenge in these vehicles as of today with the lithium-ion battery pack that are going there is the amount of time it takes to charge these vehicles, the overall performance of the pack in the vehicle, and at the same time the life of the battery. Especially when you are trying to use these vehicles for commercial applications, where we believe the adoption of electric mobility will be far higher as compared to your personal use case vehicles. So from that perspective, these are the challenges on the two-wheeler, three-wheeler, intra-city side of things. But when you move to the other end of the spectrum, which is your long-haul mobility, over there, range becomes one of the most critical factor. And what typically happens is that when you try to kind of match up that range or increase the range by increasing the battery size, uh, it becomes an unviable solution. I'll give you a very interesting analogy here. So if you consider a typical electric four-wheeler LCV, like a Tata Ace kind of an equivalent, and even Mahindra, for example, came out with a platform which is not discontinued, but Mahindra Supro electric four-wheeler LCV, that vehicle had 100 kilometers of range with a battery weight of 150 kgs. But for long haul mobility, you need at least 500 to 600 kilometers of range, if not more. And moment you kind of try to achieve 500, 600 kilometers of range, the weight of the battery back starts to become close to 1 ton on this vehicle, which is the total load bearing capacity of the vehicle itself. So either you can carry the battery or you can carry the load on the vehicle, and that becomes a very big unviability issue. So ballpark, what I'm trying to say is that different platforms have very different requirements or asks from the battery pack, and hence what we can look at from this perspective, that in the intracity scenario, you require something which has very high life, which can be charged very very quickly, at the same time can give you very high performance with a small battery size. Whereas on the long haul, you need something which can in the small size give you a very long range. So that is the kind of requirement. So in that perspective, what I believe is, while lithium ion battery as it exists today and the various chemistry that there are very good for the mid segment, and they stretch across the other two segments as well. But it works very well in the mid segment, wherein we're talking about personal use case vehicles, passenger vehicles, four wheelers, cars, and stuff like that. The short haul mobility will go to high power technologies. For example, your hybrid supercapacitors and hybrid battery packs, which can deliver much high power and give you very long life. And at the same time, the long haul will go to technologies which are particularly in the segment of fuel cells, because fuel cells can provide you much higher range on the same system weight. Now coming to your last question on maturity, so in that sense, fuel cells, particularly hydrogen fuel cell, is a mature technology, but the challenge really is of the cost on that front. And hence other technologies, like for example, we're developing aluminum fuel cell, which will be cost effective, but it will take some time to get to the market. On the other side, when we talk about high power battery technologies, that is something which is already in a maturity, very, very high maturity level. And it is already being rolled out in the market by us and by other companies around the globe as well. So that is the overall play of maturity. Obviously, lithium ion in the basic chemistry like LFP and NMC are the most mature in the segment. That's why you see almost all vehicles today running on these technologies. But eventually, different pockets will emerge and different technologies will win in individual pockets. That's it.